Hi, this is Matthias of the team The Classifiers, and I'm guiding you today through our project. So our project tackles option 4, the classification competition on sarcasm detection on Twitter data. Let me guide you through our repository on GitHub. So in our repository, we first provide the project report, which shows you in a Python notebook all the steps necessary to train a BERT model and produce the prediction results. We have also provided the progress report, which shows initial experimentation on other models. In Appendix 2, we show how hyperparameter tuning for tuning the BERT model. And finally, in Appendix 3, we provide a Python notebook that you can upload to Google Colab to run on their GPUs in case if you don't have a GPU in your computer. So to get started, you might go to the README file where we have summarized all the important information on our project results and look into the install instructions to set up your Anaconda and Python installation. Notably, we have used the simple transformers library to train the BERT model. Okay, I want to start with the appendix. And if you have followed the install instructions and started Jupyter Notebook in your working directory, you can follow along really easily. So I'm opening the first appendix. And here we show all the experimentation that we have done to check what model is suitable for our prediction task. So we have worked through a couple of models like naive Bayes, random forest, and SVM. And in our results, you can see that in comparison to the BERT model that we have used, so we are using the robust BERT model, which is an extension to the regular BERT in that it uses a larger set of data, like Wikipedia text and news articles. And you can see that RoBERTa has a much higher accuracy than these standard classic models for NLP. And you can go into all the details on our experimentation in this Jupyter Notebook. Okay, then after finding out that RoBERTa is the go-to model, so the workhorse model for us, we have employed hyperparameter tuning, which we show in Appendix 2. Hyperparameter tuning was performed on Google Colab because I don't have a GPU in my computer, and these iteratively checking the results of different training setups. So we used different learning rates and number of epochs during fine-tuning the RoBERTa model. This takes a lot of time because you have to employ many runs. So it is beneficial to do that in Colab. I have connected Colab to weightsandbiases.ai, so w&b.ai, where you can upload your statistics during hyperparameter tuning and retrieve nice graphical representations of your hyperparameter tuning efforts. For example, this nice little graph shows us that tuning or using a learning rate of about 2.74 times 10 to the power of -5, and with 3 or 4 number of training epochs leads to a large F1 score above 80. So this is the result of our hyperparameter tuning. efforts. And I now want to go to the main document to show you really quick our results. So in our main document, you can track which libraries we have installed. This is pretty standard, how we have imported the data, and how we have added context to the Twitter responses. So we have just concatenated the character strings of the context to the Twitter responses and used this as an input to our model. We have also employed eliminating stop words and experimenting with more sophisticated data preparation has not led to significant improvements in our model performance. Okay, so after training the model, which I can show you in a second. So we train using the simple transformers library classification using the RoBERTa model. And we use the parameters that I've told you before from hyperparameter tuning, which is for EPOS in a learning rate of this 2.74. And then we produce outputs on our training and test data until finally we produce the prediction output for the test data that was provided to us for the competition. What I want to emphasize really quick, you can also run RoBERTa without hyperparameter tuning. And sometimes it gives you results above baseline, but this is not, you cannot really rely on it all the time because you have some randomness in training the neural network. So using our hyperparameter values, we achieved a performance above baseline. Today, which is Sunday, the European time, 4 p.m. No, it's actually 5:30 p.m. Sorry. We ranked number 14 in the competition. So let's see if we can stay there until the end of the deadline. Okay. I think this is pretty much all I can show you about our project. Again, if you have any questions, feel free to contact us and me, especially. I'm Matthias, and thank you for listening.